Hello, Fun. My name is Nick, and I'm here at the Midwest Regional in Chicago with Team 5847 Ironclad. They were the 5th seed Alliance captains at the Central Illinois Regional 2 weeks ago, and they just jumped up to the rank 4 here at Midwest. They have an incredibly unique drain pipe for scoring in the amp and can lift their shooter to shoot over tall shield bots. Plenty more about this coming up on Behind the Bumpers.
This video on Fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
And now we're going over to Hunter to talk about the mechanics of their robots.
All right, so this year's robot is one of the best ones we've designed so far coming from our team. We have a lot of very intricate parts that needed to work together smoothly to maximize everything. So at the very beginning of our robot, which is this side, which we've technically called the back. So we are using an under the bumper intake that goes and uses polyurethane belts to pick up the note and then feed it into our launcher on our robot. So if we can demonstrate that real quickly, we can see that the note will slide under the robot, right over here, and then feed up smoothly into our conveyor system. And as you see now, we have these sensors up on the front of our launcher that will fully stop all of the conveyor system, so we can be ready to either auto aim our robot into our speaker, or we are able to score into amp by raising our elevator and then fully folding up our launcher system. So Emily, can you demonstrate that? And then once that happens, it goes into what we like to call the drain pipe, which makes the note perform a full 180-degree turn straight down into our amp. So as we do that, we can easily score into the amp with 100% accuracy, and then we are able to fully fold down and go under the stage. We are able to fully squeeze under the stage and outmaneuver robots that are not able to. Another big thing we're happy with is once we fully catted out our elevator and designed it, we realized that we can also have our elevator raise up with the shooter and then aim over robots who are playing defense on us. So Emily, we are able to fully aim above some robots that might be playing defense, so they cannot block our shots when we are shooting into the speaker. That has allowed us to outperform some teams who are strictly defense based. And then with that, we are able to quickly improve our cycle time just by that simple thing that was already put onto the robot. And then one of our biggest systems is this custom gearbox that we made. It has a 93:1 gear ratio, and we use our CAD software to fully design this out and able to perform our shooter to fold up and score into the drain pipe as we skull, and then either auto aim with our swerve drive system that we have with it.
All right, that's very interesting, Hunter. Now we're heading over to Bryce to talk about all their electrical systems.
All right, so this year we have started, and this is probably our best wiring we've ever done for this robot. And I'll go and start with LEDs. We decided to do LEDs on the robot this year as indicators, and we have different signals for it. So when we have a successful intake, they will flash green and then go to yellow. And if we want to score into the amp, they will go purple. And then for your speaker, they're just the regular rainbow that we have right here. And then we got a couple of sensors. We got a sensor here on the back of the intake to determine, and it'll let this know that we have a successful intake, and it'll also let the LEDs know. And then we also have a sensor over here on the shooter to determine if we have it, and it also helps us know that it's in our shooter so we can store it in the speaker. And then we're also this year using a orange pie for our vision and cameras that help us read on the April tags, and also tell us where the notes are. And so then we also have we started using Krakens this year on a robot, and we've had really good luck with them. And yeah.
Thank you very much. Now we're heading over to Shamrock to talk about their software.
So this year is actually our first year coding in Java. But years prior, we coded in LabVIEW, which is a graphical language, programming language. And because we're using Java, this year we're able to use Path Planner, which is software. We're able to draw paths. And we use this for posts from April tags, from a vision to correctly calculate what drive speed, what swerve angles, and what else we need in order to make a successful auto. And in order to shoot a robot, to shoot a nodes, we gather many data points of different distances from a speaker and a turret angle, or launcher angle, and then we interpolate for angles, for distance, and find what speed of a shooter and the angle that we need in order to make a successful speaker launch. And in order to shoot with an elevator, we calculated for 0 to 1 factor of the turret angle on the bottom of the elevator to the top of the elevator, and as a multiplier, apply it to the turret angle to successfully make it into the speaker.
Thank you, Shamrock. Now we're going over to Emily to talk about their vision systems.
So this year is kind of like one of our beginning years really using the April tag system as vision. We started it a little bit last year, but we've really gotten into it this year. So we have 3 cameras on our robot. We have 2 up front on our swerve modules, and then we have 1 over here to kind of give us like a larger view of the field when we're further back. So the ones on our swerve modules are enough that they're tilted at 45 degrees, kind of, so we can see we can always are guaranteed to see at least 1 April tag. And the biggest thing about using this vision is it allows us to figure out our pose on the field constantly, which means that our driver is able to consistently auto aim himself to the speaker, and then the aux player is able to use the auto aim, and because of how many April tags there are in the field, it's consistent from any distances that our shooting is possible. So it helps also, like Shannon said earlier, when we're in autos, making sure that everything is right and that so we can start our auto kind of in any orientation, and as long as we can see the April tags, the robot will automatically aim itself and shoot based off of where the April tags are.
All right, thank you very much, Emily. That's very cool. Thank you so much for your time, Ironclad. I wish you the best going into Alliance selections. You're ranked 4, which is good for now. I wishing you all the best, and thank you so much for your time.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.